Hi guys, welcome back to my channel, Shear Analysis. In this video, we'll discuss about the shear force and bending moment diagram for a cantilever. Now what we have right here is a cantilever beam with a load somewhere along the beam and a moment at the end of the beam. The first thing we have to do here, the first step to take, is to draw a free body diagram for this question. Now we have the free body diagram. We know that the cantilever, which is a fixed support, has three reactions, which is the vertical, the horizontal, and the moment. Now the horizontal will not be needed here because there is no other horizontal force in this beam, and so this horizontal force will be equal to 0, so there's no point adding it or writing it. And so we're left with the vertical force and the moment, which is acting about this point, and then the 70 kilonewton force, and then the moment 200 kilonewton meter. So now that we've got to the free body diagram, the next step is to find the support reaction, and we have only one support, which is RAY. And to get the support reaction, we have to add all the forces acting on the beam, and we have just two, which is RAY and the 70 kilonewton meter. So we have RAY minus 70 is equal to 0. Therefore, RAY is equal to 70 kilonewton. So that's the support reaction for this beam. Next, we move on to finding the shear force. And we have shear force at only 2 points, RA and at B, because at C there is no support, it's just a moment. So we're going to look for the shear force at A and shear force at B. So shear force at A is equal to RA, which is 70 kilonewton. Shear force at B, which is equal to RA minus 70, which is equal to 70 minus 70, which is equal to 0 kilonewton. So now we've gotten the shear force for both A and B. We move on to the next, which is bending moment. Before we start solving for bending moment, we first have to look for the value of MA, which is moment at A. So to do that, we either take moment about point C or about point A. So here I'm just going to take moment about point A. If you take moment about point C, you get exactly the same thing. So taking moment about point A would have a minus MA, because obviously it's an anti-clockwise moment, plus 70 times the distance, which is 6, plus 200. 200 is a moment already, so you don't need to multiply by any distance. So equal to 0. So we have minus MA plus 420 plus 200 is equal to 0. We have minus MA plus 620 is equal to 0. And therefore we have minus MA is equal to minus 620, so the minus will cancel out. So we have MA is equal to 620 kilonewton meter. But looking at the question, MA is an anti-clockwise moment, so therefore the moment is a negative one. So we move on to finding the bending moment. So, bending moment at A is equal to MA, which is equal to minus 620 kilonewton meter. Then, moving on to the next one, is bending moment at B, which is equal to minus 620 plus, now we can add the RA to it. So, an RA is 70, and the distance between RA to B is 6. So we have plus 70 times 6, which will give us minus 200 kilonewton meter, which is for the bend moment at B. Now moving on to C, we're going to divide C into two parts, C left and C right. So for C left, the bend moment remains the same because there's no other force acting here. So we have equal to minus 200 plus 0, which is equal to minus 200 kilonewton meters. So the bend moment at B and at C remains the same. Now for C left, we have minus 200, which is like the previous bending moment which we got for C left, plus 200 is equal to 0. and that's how you know that this bend moment is correct. But we can also do it the other way, starting from the beginning, starting from where we start from, which is at 0.8. So we could also say minus 620 plus 70 times 10 minus 70 times 4 plus 200. So resolving that, we're still going to have a 0 kilonewton meter as the answer. So that's that for shear force and bend moment for a cantilever. Now we move on to drawing the diagrams. So first, for the shear force, we have just two values, which is 70 and 0 kilonewton. So at A we have 70. I'm just going to mark that now, and it stands on to the next one, which is B. That gives us 0 kilonewton. So the shear force diagram is going to look like this. Now this is a positive shear force for the shear force diagram. So that's all for shear force diagram. We move on to the bending moment diagram. So for the bending moment diagram, at point A we have 620, which is a negative moment. So we'll have something like this, and we're going to mark 620 here. The next is at B, which is minus 200, same. The next is at C, which is the same as minus 200. So when you look at B to C, we notice that we have like a zero slope there because it's the same value, so it's just going to be a straight line. So what I mean is starting from 620, we have a line down to 620. Now from 620, which is at point A to B, we'll have an inclined line, which is a positive slope because it is moving from a lower value to a higher value, which is from minus 620 to minus 200. So that is positive. And then from B to C, which remains the same at minus 200 kilonewton meter, and then back to 0. So yeah, that's all for bend moment and shear force for a cantilever support. So if you learned something from this video, if you enjoyed watching this video, please do also like this video, share and subscribe so you get notified whenever I'm posting subsequent videos. So that'll be all for today, guys. Thanks for watching.